Alright, welcome back to the second part of this video, just talking about the unit circle. In this video, we're going to talk about how do we actually use the unit circle now that we have our degrees and our coordinates labeled on our unit circle here. So what we need to do is we need to talk about where do our trig functions show up on here. So the same sine, cosine, and eventually tangent actually show up on this circle, and we can use it to find our exact values and find different angles as we go. I am going to not talk about tangent today. We're going to add that in next week. So we're going to focus on sine and cosine. So what I want to actually do is I want to bring back one of my triangles here. I'm going to bring it back my 30-degree triangle. Okay, and what I want you to do is, as we start to look at this, I want you to think about, well, if I was asking you to find the sine of 30 in this triangle, what would that look like? Well, the sine of 30 would be opposite over hypotenuse. So my opposite from the 30 is the 1/2. My hypotenuse is 1. Well, anything over 1 is just itself. So this 1/2 here is my sine. Okay, so it looks like that's my 1/2. I see that here. That's my y-coordinate. Let's see what happens when we go to our 45-degree triangle. Okay, for my 45, I would do opposite again as the square root of 2 over 2 over 1. Well, that's my y-coordinate again, and I can see it's my y because it's my vertical piece. And even if I go to my 60-degree triangle, I'm just going to leave this one on here, I can see that again, it's my vertical piece. So this y-coordinate that we have here is always your sine value. So sine is always your y-coordinate as we go through all of these. So what that means is we can actually find sine of other angles as well. So like sine of 0 should be 0. Sine of 90 should be 1. This is the calculator trick that I had you using before we even knew what degrees and other things were. To check your calculator, it's right there. Sine of 90 is equal to 1. Okay? I could do something like sine of 180, that's 0. I could do sine of 135, that's the square root of 2 over 2. You can check all of these other ones just by knowing that your sine coordinate is your y coordinate. Okay? Now you might be asking, well, where's cosine then? Okay? And some of you might already be seeing it already. If I put 30 degrees on here again, cosine, well, that's adjacent over hypotenuse. Well, adjacent is the square root of 3 over 2. My hypotenuse is still 1. So my adjacent side, the square root of 3 over 2, is just my answer. My x-coordinate, or my horizontal piece, this piece right here, is my cosine. And if I stack my other ones on here as well, these ones are going to be a little harder to see because they kind of cover each other up. But if I put my 45 on there, I would have the square root of 2 over 1, which is the square root of 2 over 2. There's my answer. 60 degrees, if I put that on here, my adjacent side is the 1/2 over 1 is 1/2, so it's now my x-coordinate. So what we can think of here is cosine is always going to be your x-coordinate. Okay? And the way I actually want you to think of this, I don't think of these as two separate things. I think of them as one. I always think of an ordered pair as cosine, comma, sine. And the way I always remember that order is it's simply in alphabetical order. It's C and then S. So cosine always comes first. So what we can do then is we can start to find some exact values for different angles. The first ones that I want to focus on are just going to be in the first quadrant here. So if I asked you, say, for cosine of 30 degrees, you could simply say it's the square root of 3 over 2. Okay, because that's my x-coordinate at 30 degrees. I could ask you for cosine of 60 degrees. Okay, which is up here. That's 1/2. I could ask you cosine of 45. That's the square root of 2 over 2. I could ask you for sine of 30 of 1/2. Sine of 45 is the square root of 2 over 2. Sine of 60 is the square root of 3 over 2. So you can start to see that I know all these values very quickly. What I want to actually pull your attention back to is this worksheet that we did last week. Okay, in this worksheet, you can see that sine of 30 is 1/2, and we could do that using our special right triangle. So what I did to get my sides earlier was really this same thing, but now we can see it. Okay, now we can actually put it to use in our unit circle. The other reason the unit circle is very helpful is we can start to extend beyond just our special right triangles that we had of 30, 45, and 60. I can go to 0, 90, 180, 270. I can also do all of these in between angles in my other quadrants where those negatives and positives show up. Okay, and so what I want to do is I just want to go through some different practice questions that you might be asked as part of your homework or your quiz that's in this week as well. Okay, so I'm just going to list a couple up here. We're going to start with simply sine of 30. Okay, which we've already been talking about. Sine is your y-coordinate, so I go to my y-coordinate at 30 degrees. 30 degrees is right here. Y-coordinate's 1/2, so I answer this with simply 1/2 as my answer. Okay, I might ask you a more difficult one. I might ask you cosine of 135. Cosine of 135, you probably don't know off the top of your head, but I can go to 135. I know that cosine is my x-coordinate, so I'm looking at my x-coordinate at 135, and that is a negative square root of 2 over 2. So my answer is simply negative square root of 2 over 2. And it is important to make sure you get your negatives and positives right on these as well. So those ones are pretty straightforward. I'm not going to do a lot of those because for the most part, you're just reading those off of your unit circle. Okay. Next one I want to show you is this. Cosine of theta is equal to 1/2. And the question that comes with this is I actually want two values of theta, specifically between 0 and 360. What that means is I want two values of theta that fall between 0 and 360. Well, theta we know is our angle measure. So they're asking me for two angles where cosine is 1/2. Well, cosine we know is our x-coordinate, and I want a 1/2. So I'm really asking you where on your circle is the x-coordinate 1/2. And we're really talking about just positive 1/2. I don't care about the negatives. So if I look, I have 1/2 here at a 60 degrees. So that's one of my angles, 60 degrees. And the other one should be in that same kind of rectangle that I'm working with, but I need the positive one. So 120 is negative, that one doesn't work. 240 is negative, that one doesn't work. But 300 here I have a negative, or another positive 1/2. So I have 60 and 300 are my two answers there. All right, so be careful with something like that. The other thing is I can also ask you just a general question about angles that don't fall in this. Okay, I could simply ask you something like sine of 172. Okay, now the question here is going to be a little bit different. I'm not going to ask you for the value. I'm going to simply ask, is it positive? Positive, if I can spell, negative, or is it 0? Okay, well, 172 is an angle measure. It's not one that I have labeled, but I could figure out where it is. 172 is more than 150, but less than 180. So I know I'm in this part of my triangle over here. And I know I'm talking about sine, which is my y-coordinate. So the question is your y-coordinate over here positive, negative, or 0? Well, if I look, I have that. It says my positive coordinate is in my y. So I would say here, this is positive. And that's my answer. So those are the types of questions that you're going to be seeing in this section. I know this was kind of quick, so if you need to go back and rewatch some of this, that's fine. But these are going to be the types of questions that you see using the unit circle. Next time out, we're going to talk about these things called radians and how those are involved in kind of setting up this unit circle in a slightly different way.